Right, if we are going to sketch in vertex form, the first thing that I need to do is consider what are the dilations, what are the reflections, what are the translations. What was the word that we used to remember that last lesson? Dirt. All right, so we've got a little I there. The I actually means nothing. I just want you to remember the DRT. So, in this example, is there a dilation?
Yes.
Yes, what's the dilation? How do I write that formally? It's written on your sheet of paper. What's the language that I want you to use when you write down that dilation? So it's a dilation by a factor of 2 from the x-axis. Perfect. Now, if you're just doing quick sketch graphs, you don't have to write that down every time. But if you do not use the formal language in an assessment task, you will not get a mark. If you just say dilation of 2, I'm not giving you a mark for that. All right, I need to know what the factor is and where it's from, because there are dilations from the y-axis as well. Okay, second thing, are there any reflections? No, how would I know if there was a reflection? It's not a negative graph. There would be a negative sign out the front here if it was a reflection. So there's no reflections. Don't know why I put a little mark on that. That's not how you spell reflection. No reflections, nil. So if we want, that just lets us know it's going to be a little smiley face parabola. Perfect. Are there any translations?
Yes.
Yes, where are those translations?
The translations are, it's 4 to the left and 5 up.
Now we've got 4 units left. There's a little bit extra for our formal language that I want you to use. So 4 units left, which is parallel to the x-axis. I think that was Tamsin's voice, maybe? Okay, remember, this value in here creates the translation. So if that's a minus 4, the 2 negatives made it a plus 4. Why do I care about there being 2 negatives? Because I've got to have this sign as a negative. And that value is my h and tells me where I'm going, left or right. So it's minus 4. The minus 4 is my h value, and h tells me that that will go to the left 4 places. Okay, where's the second translation? Where's the second translation? Call it out. Up. And what's the formal bit that we add to that? Absolutely. So if I'm going up and down, I'm moving with the y-axis. I'm going parallel with the y-axis. Again, you don't have to write these out every time. I'm doing it now because repetition helps you remember what to do in an assessment. And if you're asked to describe the translations, you must use that formal language. How do I actually put this onto a graph? Well, the first thing I do is I'm actually going to say that this graph's a little bit skinnier. So it's kind of, that's an obscure thing. How do I know if that's a skinny graph or if that's a skinny graph or that's a skinny graph? That's not something like, it depends on what your scale is, doesn't it?
Yeah.
Right, your scale determines whether it's a skinny graph or not. So I don't actually stress about sketching the skinniness of a graph, all right? What I'm going to do first as I sketch these, I'm going to first look if there's a reflection. There's not. Then I'm going to move my graph 4 places to the left and 5 places up. So here's my axes, and I'm really simply going to say 4 places to the left, there's -4, 5 places up, here's the point on my graph, and there's no reflection, so it goes like that. improve that, I'm going to put my coordinates of my turning point on there. We're getting better. But I would still not give this full marks. Because I only have 1 point marked on my graph, there's not enough information to know if it is a skinny graph or a wide graph. I haven't got any scale or sort of like size to sort of find those other values. So to do that, I have to show the important features. What's the other important feature that this graph is going to have that I have not put on there, Edith? The y-axis intercept. So define the y-axis intercept. That occurs when the x value equals 0. So I'm going to sub in x equals 0. Substituting x equals 0 looks like this. That was my original equation. So it's y equals 2 times 16 plus 5. 2 times 16 is? Plus 5? 37. So this is my y-axis intercept. A few people talking over me makes it hard for me to concentrate and talk at the same time. Y-axis intercept at 37. And I kind of look at my graph now and go, the scale's all up the creek at the moment. Like, where am I fitting on 37 if that's 5? So I would usually find that value before I did my graph to help me give a little bit of representation. Then, instead of making 5 way up here, I'm not overly worried about the scale, but I shouldn't say that's 5 and that's 37 and then that's 0. Like, that's way out of whack, isn't it? Yeah, don't do that. But if I'm drawing a sketch graph in my workbook, it's perfectly fine to just say, well, if 5 is down here somewhere and 37 is going to be up here then, isn't it? Like, there's enough variation there for that to be reasonable. Here's my turning point. Parabola shape. And because these graphs are symmetrical, I'm going to kind of make it roughly symmetrical. That's okay. I'd accept that for sure. What I wouldn't be happy with is if this side then went like this. I would take a mark off for that graph. That is not symmetrical enough. All right? That's almost going straight up as well. So it does not have to be perfect, but there's got to be an element of goodness to it. All right? Label your coordinates. This is when x is 0, y is 37. This is when x is minus 4, y is 5. Do I need to find the x-axis intercepts?
No.
Why not?
There isn't.
There isn't any. Don't waste time doing something that doesn't exist. That would be a bad choice. That's all I've got to do for this graph. All right, example 2. Minus 2x minus 2 squared plus 8. Okay, repeat, repeat, repeat. If we do this enough, it'll stick in our heads. What's the first thing I do?
Dilation.
Yeah.
Okay, is there a dilation?
Yes.
Where is it?
By a factor of 2 from the x-axis. Yeah.
Is there a reflection?
Yes.
What is it?
Yes.
Okay, we describe our reflections as a reflection in the x-axis. Perfect. Is there a translation?
Yeah.
What is it?
2 to the right, 2 units to the right. 8.
And the one to the right is parallel to the x-axis because left and right is parallel to the x-axis and up and down is parallel to the y-axis. And if I wanted, I would just quickly start drawing my graph, but then often these first sketches of the graph end up being rubbish because of where my axis intercepts are. But we're thinking we've got a graph that's gone 2 places to the right, so that's 2, 8 places up. It's like this, and it's going to be upside down because there is a reflection. It'll probably look something like this. How do I find out if this graph's good enough? What are the key features that I need to show? Coordinates, okay. Have I done enough now? No. What else do I have to show?
The y and x intercept.
Which would you find first, the y-axis intercept or the x-axis intercept? Why would you do the y-axis intercept first? Sometimes the x-axis doesn't have one. Also what Bella said, why not? And I love the why not why first. But as somebody else said, because it's easiest. The y-axis intercept is usually easier to find. So I normally find it first because I get a little sort of bit of a confidence boost from getting the easy stuff done first. My shorthand is y-intercept when x equals 0. This is my shorthand for saying I'm finding the y-intercept, and I'm doing it by substituting in x equals 0. So y equals -2 times 0 minus 2 squared plus 8. What is 0 take away 2? -2. Square it. 4. Times by -2. Plus 8. 0. So when x equals 0, y equals 0. So I actually need to have a point here. Now, I can actually save some time. Do I need to find the x-axis intercepts? Are there x-axis intercepts? Yes. So I do have to find them. Absolutely, I've got to find them. But I've already found one. And because I know these graphs are symmetrical, this one would have to be at 4. Because if the turning point's at 2 and that intercepts at 0, that means I've gone across 2 between those 2 points. Because of symmetry, I have to go across another 2 to find the other one. So I can use those shortcuts. I don't have to substitute in y equals 0 to find the x-axis intercept. Have I labelled all of my key features?
Yeah. Yes.
Yep, y-axis intercept, turning point, x-axis intercepts, all labelled. So I have all key features, and because I've got all of those key features, I have shown the dilation, I have shown the reflection, and I've shown the translations. Okay? Repeat, repeat, repeat. Let's do another one. Now, I can hear a few pens clicking, which means there's probably a few people writing this down. If you want to write all of these down speedily, you can. I will post up this video later. But also, you might choose to put in some other examples. Remember, I want you to be thinking about what examples you need. Is my equation in turning point form or in vertex form? I've got a yes. Anyone want to take a different? Yes. One person confident. Can anyone else give me an answer? Is it in turning point form, vertex form? Now got a no, but I've still only got 2 people who have spoken. What do you think, folks?
What did Calder say?
Sorry? I don't care what Calder said right now. I want to know what everybody else's opinion is. What do you think?
No.
What if I did this?
X plus 3x minus 3. Oh.
Is that in turning point form?
Yes.
What's H?
0.
What's K? -9. Okay. I could say that this is in turning point form, or I could say that it's in general form, which we're going to do in our next lesson as well. The point is, I could actually just make this really simple alteration, that's the word I was after, my brain's not working. This really simple alteration to my equation, I haven't changed its value because I've stuck a 0 in there. Taking away 0 won't change anything, but now we can really clearly see that vertex form. It's helped me visualize what's going on. So, is there a dilation? So, there's no dilation. Is there a reflection? No, there is not a reflection. Is there a translation?
Yes.
What is it?
9 units down, parallel to the y-axis. I'm getting good at this.
You are getting good at it. That's why we do repeat, 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 because it starts to stick. And the more you practice, you can actually write that out pretty quickly. It really doesn't take long. So here's my graph. Few people talking, it makes it hard for me to concentrate. I've gone down. Thank you. I've gone down 9 places. So this is when x is 0, y is minus 9. There was no left or right. There was no reflection. So it's just going to look like that. Do I need to find some other points here?
Probably.
Yes, I absolutely need to find the x-axis intercepts. How do I find an x-axis intercept?
Do you make y equals 0?
I do. And this is my shorthand, x-axis intercept. So x-int is when y equals 0. So I'm going to substitute in y equals 0. My rule becomes this. Now it's not minus 9. We've learnt 2 methods for solving quadratics. What's the first method that we use if we're going to solve a quadratic equation? Null factor law. Do we have the null?
Yep.
Do we have the factors?
Yep.
No. This is not 2 things being multiplied together. They are not factors. So I've got to factorise this. What are my strategies for factorising? Is there a highest common factor? No. Is it a DOPS problem? Yes. So when I use DOPS, it's x minus 3, x plus 3. How do I solve using the null factor law from here? Good. So we solve it in parts. Either x minus 3 equals 0, in which case x would have to equal 3. So that's the point x is 3, y is 0. Or x plus 3 equals 0, in which case x equals negative 3, which is the coordinate negative 3, 0. Which coordinate's which? And the one on the left is the negative 3, 0. Now, I know I just asked a really silly question by saying which one's which. Obviously, this is the minus one, and that's a positive one. But I have seen many students do them the other way around, and you will lose a mark for putting them in the wrong spot because that's just a silly error. Don't do that. All right? Do I need to do anything else?
No.
Have I got the turning point?
Yeah.
Have I got the y-intercept?
No. Oh, yeah.
Have I got the x-axis intercept?
Yeah.
Intercepts, yes, we've got all of those key points. One more to go. Remember, this is repeat, 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 because we're building our skills, we're building our experience, and we're getting more confident by doing it over and over again. Okay, is it in vertex form?
Yeah. Like, no, it's not. It's in
No. All right, I really need you to tune into this one, folks, because we have not done one like this before. This is not in vertex form. How do I know it's not in vertex form? There's no brackets with a squared on the outside. So does that mean that the turning point is now at y equals negative 1? It's gone down one place? No, it does not. So we cannot do this yet. If we're going to use vertex form, I actually need to change it into vertex form. Up the back, it's distracting. Please stop talking. The way we change this into vertex form is we're actually going to use one of our factorising techniques that we learnt. We're going to use completing the square, because the first steps of completing the square will actually change this to vertex form. So flick to your summary journals. How do I complete the square? You missed one little bit. All right.
And then the first bit is perfect square, so it's x plus 4 over 2 square in brackets.
Not quite. It's whatever's in here.
Yeah, that's what I said, 4 over 2.
You said squared in brackets.
No,
We need to
like
have...
the whole thing's in brackets.
Okay, right. Maybe you're okay. Good. And then I'm actually going to do this in 2 steps just so we can see everything. I'm not going to leave it like this. Why am I not going to leave it like that?
Because it's a young fraction.
Because it's just 2. 4 over 2 is just 2. 4 over 2 is 2. 2 squared is 4. Negative 4, take away another one.
Minus 5.
Is it in vertex form now? Yes. Okay, does it have a dilation? No. Does it have a reflection? Does it have a translation? What is it?
Left 2. 2 units left of the y-axis. Parallel to the x-axis.
Does it have another translation?
Yeah.
What is it?
It's down, parallel to the y-axis. Got it there.
So we can start sketching, but we have to keep in mind that this first sketch might be a little bit dodgy. So I've gone 2 places left, 5 places down. So I'm going to say this is my first crack at sketching the graph. -2, -5. Have I got all of my key points on there? No. What do I need to find as well?
X-axis intercepts.
And?
Y-intercepts.
Okay, what's the x-axis intercept? Am I going to start with that one?
Probably not. Can we do y, please?
What, can we do y, please? Yes, we can. Y-intercept is when x equals 0.
Yeah.
So if x equals 0, y equals
Minus
0 squared plus 4 times 0 minus 1, which is -1. So when x was 0, y was -1. Now hint, we're going to learn about general form next lesson. This is what we call general form or standard form. This value on the end, when we did quadratic formula, we called this c. That value on the end, that c value, that constant, will always be the y-axis intercept when we're in standard form. So at this point, x is 0, y is -1. Trying to go fast for you here, folks, so that you're not listening the whole time, but I know I've been going along a while now. Let's just finish this off quickly. X-axis intercepts. The x-intercepts are when y equals 0. How do I solve a quadratic? We've got 2 methods for solving a quadratic.
Factorizing null factor law and
Null factor law
quadratic formula.
or the quadratic formula. Now, I would actually use the null factor law because doing this step, we actually did half of completing the square. So I've already done the first half of completing the square for factorising. Let's just continue from this step. Now the last step for completing the square This is the difference of two squares. So I'm going to have two brackets, one with a plus, one with a minus. I put the square root of the first part in the first spots, which becomes x plus 2 and x plus 2. Square root of the second part in the second spot. Not just 5, it's got to be the square root of 5. If it was 5, it would have been a 25, you're right. Now, I have to solve this. This is the null factor law. How do I solve null factor law? I do it in two parts. So the first part, x plus 2 plus the square root of 5 equals 0. What's the opposite of plus 2?
Minus 2.
What's the opposite of plus root 5?
Minus root 5.
So it's x equals minus 2 minus root 5. And then I've run out of space, so I'm just going to squeeze it in up here, even though I hate it when we do this, but I'll manage. The other part is x plus 2 minus the square root of 5 equals 0. What's the opposite of plus 2?
Minus 2.
What's the opposite of minus 5?
Plus 5.
So it becomes minus 2 plus root 5. So this is actually an x-axis intercept. X is minus 2 plus root 5 when y was 0. Oops, don't need the extra bracket. And this one was also an x-axis intercept. X is minus 2 minus root 5 when y is 0. How do I put them on my graph? Sorry? Prob's just that. Now, I've got the spots already. I've got an x-intercept and an x-intercept. We've written them as coordinates already. Which one am I going to put where? Which one's going to be the bigger one?
Plus.
The plus one. Which one's going to be the smaller one?
Minus.
Which one's the minus one and which one's the plus one?
The minus 1 is the one down the bottom.
This one's got two minuses. It's going to be smaller than a minus and a plus, isn't it? Yeah? So that means this coordinate is minus 2 plus root 5, 0. And this coordinate is minus 2 minus root 5, 0. And if you drew that, that would be a perfect graph with some great mathematics. We've done completing the square. We've done factorising using the null factor law. We've substituted in x equals 0 to find the y-axis intercept. We've got it in turning point form. Everything that we've basically done this year rolled into one question.